So I recently picked up this book, Humble Pie, When Math Goes Wrong in the Real World by Matt Parker. And I've been reading through it, and here on page 179, there's this explanation of an issue with binary systems and arithmetic that he goes into some detail about causing calculation errors on calculators. So in particular, he's talking about the iPhone calculator that he uses. And the calculation is 75 divided by 14, and then minus 5, and then multiply by 14. And rather than getting the expected answer of 5, it gives things like 4.999999994, or a bunch of 9s, or just over 5. And here he's saying the iPhone will see the correct answer, but then when you tilt it into scientific mode, it gives the 4.99999. And unfortunately, of all the calculators I do have, the iPhone is not one I have access to. But I figure we can test all the other ones that are in my collection. I don't think it's worth testing like the basic 4-function calculators. They're gonna most definitely cause the error, and the mechanical calculators will obviously result in a something that isn't 5 as well, but I figure we give it a go. So I guess since he's talking kind of specifically about the iPhone calculator, I guess we can start here. I have the Android calculator, so 75 divided by 14, and then I'll be pressing equals in between because there's a tendency maybe to take the result rather than storing a higher precision result within the system. So, and then we subtract 5, and then multiply by 14, and we have 5. And I don't know if Android has it, but we can try to tilt and get some sort of other mode. And that's not entirely surprising on the Android system because you can see if we do something like just bring up pi, it has this variable precision engine which gives you lots and lots of digits to work with. So Android calculator gives you 5. And then what else do we got? Okay, well, we got the NumWorks app, and unfortunately it's an emulator of the NumWorks calculator, but you still have to navigate using the buttons themselves. There's no touch screen, which I guess is a true emulation of using the calculator. But 75, oh, that's not right. Where's my clear? And then, well, it's giving us a little approximate sign. Now do I have to bring up answer minus 5? And then answer times 14. And we're back to 5. So it's giving us the approximate results in decimal, but it also seems to be displaying them in fraction. And we are back to 5 on the NumWorks emulator. Okay, sorry. Of the HP Prime emulator, I just have the light version here. 75 divided by 14 equals answer minus 5, and then times 14. And here we get the result of 4 decimal, bunch of 9s and a 6, which is kind of curious, but the HP Prime actually has a CAS mode, a computer algebra system mode. So trying it in here, it stays in fraction form. Is that answer -5? Yeah. And then here we go. So we're back to 5. So that's pretty unsurprising. We can try here in this is the free 42 app, which is an HP 42 emulator. And so we gotta go 75, and it's RPN, so we enter that into Y. Then 14 divide 5 minus 14 multiply, and the result is 5. And just to make sure, we can actually bring up, so we can bring up all units of precision, or all digits of precision, and it's still 5. So that's all the emulators I have, or all the software calculators I have on my phone. So I guess maybe you can check out the Nspire next. I don't have the Nspire 2, but I do have the CX CAS. So, and unfortunately, I bought this one used for pretty cheap, but the battery is no good on it, so I gotta constantly have it plugged in. Switching between algebraic and RPN is kind of tricky. So there we go. Answer of 5 from the Nspire CX CAS. And I guess we have the 9750 third generation from Casio. So 75 divided by 14. And we got a decimal answer right away instead of a fractions answer. This doesn't have, at least the base unit doesn't have access to a CAS. -5. But we're back to 5, and then we can switch between standard and decimal just to see if there's something that it'll give us weird. But no, it looks like it brought us back to 5. And I guess we can stay on the Casio train. Maybe we'll do this first. So, pretty popular one, the 991EX. And 5 divided by 14. And right away, you can see it's staying in fractions. So, it's not messing around at all. Time. Oops. Start over. Nope. 75 divided by 14 minus 5, and then times 14. There we go. And we're back to 5, and we can just quickly check that it's, yeah, 5 times 10. Ugh. Okay. So that one stays, or that one gives us the 5. The step down from the 991EX is this, the 991ES. And turn it on. 75 divided by 14. And this one's in decimal approximation, so it is a step down. I'm assuming it has the same processor and everything, though, or at least architecture. Minus 5, and then times 14, and we are back to 5. Yeah. So even the step down from the EX still gets the right answer. Oh, we can try this. Well, we have the Solar 2. This is kind of the lowest in the scientific range from Casio. It's like a $10 calculator. So 75 divided by 14 equals, and then minus 5, and then times 14, and we are back to 5. So even like this $10 scientific kind of lowest level calculator from Casio gets it, but also can check the older version. This was the Solar 2, and this is just the Solar fraction. So minus 5 times 14, and we are back to 5. And presumably if there was something over here low down, it would still try to give us like 9 decimal places, just like when we did the initial 75 divided by 14. So those both seem to work. Stepping back in time, well, this is kind of similar to the Casios in that I have a TI-89 titanium, or I guess it's like a TI-89 Ti. I'm going to be honest, kind of ran out of batteries to put in all of these things to have them going at the same time. But this is pretty much just the new version of this. So if it works on the TI-92, it's going to work on the 89, I would assume. So we can bring this one up. 75 divided by 14 equals, and again, this also has a CAS or a CAS, and we're staying in fraction display. So answer minus 5, so now we're 5 over 14, so I'm pretty confident when we multiply by 14, it will give us a result of 5. So don't think we've actually found a calculator to not do it yet. I guess regular mode on the HP Prime emulator anyway. Here I have a Sharp. Just picked this up the other day, and I haven't used it too much, but it looks like it has some nifty functions. So, and it looks like by default it's giving us mixed fractions, but still fractions. So I'm thinking I see, or I think I see where this is going. And then, yeah, 5. It even gives us a little decimal place there. So that one's good. And TI-83, classic. This is my high school calculator. Not this one specifically. This is what I used in high school. This one I picked up, I think, for like $5, and it still works. So divided by 14. So this one's giving us a decimal answer. So maybe, and then times 14, and we have a 5. So the TI-83 that everyone knows and loves, still good for this this test, I guess. And then TI-82, which is, I guess, the predecessor to the 83 in some way or another. The naming scheme for the TI-8 whatever series is all over the place. I think the 85 came first or something like that. And again, we're getting a decimal answer, so maybe generation to generation they did some upgrades in the software. But it looks like this one gives us the 5 as well. And what haven't I done yet? I'm starting to lose track, to be honest. We can go with this. If it works, the battery compartment is a little tweaky on this. Okay, so this is the Hewlett Packard 18C. It's actually a financial calculator, and there it goes. Let's see if we can fuss with that here. Okay, so let's bring up all the zeros. There you go. Hopefully this survives. It's an HP calculator with algebraic entry. Okay, and then we're going to multiply 14, and it gives us 5. So that one's good. And I think that one's 1986. So that one works. 32S. Is this an 89 or 91? I can't remember. The Free 42 emulator that was on my phone, I believe the 32S has the same or similar architecture to the original HP 42. So I'm pretty confident this will be fine as well. RPN, so 75 enter, then 14 divide, 5 minus, 14 times, and there we go. So 32S gets the answer. And I guess the oldest ones on the table might be this. So the classic, this is the HP 12C. It's first sold in, I think, 1981, part of the Voyager series of calculators. Let's bring up precision. So we got all the digits and RPN. So 75, enter, 14 divide, minus, and 14 times. And there we go. So 1981, we went all the way back there. And I think other than the prime not in CAS mode, every other calculator on the table did it till now. So there we go. So now we have this rounding error introduced, and it gives us almost 5, but not quite. And I guess just to make sure, that's the business financial calculator of the series. So we'll bring up the 15C, which is the scientific calculator of the series, or there's a couple of them, but this one's kind of the fancy scientific version. So let's bring them, fix 9. So now we have all the digits available. 5 minus, and then 14 times. And yeah, the same answer as the 12C. So probably the Voyager series all gives us the rounding error. But going back to 1981, at least for the scientifics on the table. So like I said, I'm pretty confident any of the 4-function or the adding machines that I have would give us the error, as well as the mechanicals are going to obviously introduce the error. It's a pretty good book, though. I just thought I'd give that a try, since I obviously have so many calculators to test on. But if you have one that, if you have a calculator that I didn't test, you might want to give it a try to see what happens. Or if you have an iPhone, give it a try, since that was the prompt for why it seems to be added into the book. But yeah, I guess that's it. Yeah, thanks for watching.